In this video, I'm going to show you multiple methods for how to factor polynomials, but just doing factoring with a GCF. So the first problem we have here is negative 3x to the fourth plus 15x squared. And one of the methods that you can do is actually to write out all of the factors for each of the terms in your problem. So if I look at just this first term here, so I know I have negative 1 times 3, okay? I've got x to the fourth, which means I've got 1, 2, 3, 4 x's, okay? So that's the first term. Then if I look at the second term, and I'm going to pop a different color up here, let's go red. My second term is a positive 15x squared. So if I do, and if you guys remember this from, different classes you've taken, little factor tree, the only way you can break up is a 15 is a 5 and a 3. Yes, you could use 15 and 1, but that's not terribly helpful because you want to break up the 15. So I've got 3 times 5, and then I have x squared here, which means I have 2 x's being multiplied together. So let's go ahead and remove that 15 there. Now, to figure out the common factor, what I want to look to see is what numbers show up in this purple list and also show up in the red list. And so I can see that I have a 3 in both of my lists. I have an x in both, and I have another x in both. Okay? So putting this all together into the actual factored form, the pieces that I just circled up, the 3 and the x and the x, the 3 and the x and the x, that's what's called the actual GCF. That's the greatest common factor. So we have 3x, and there were 2 x's, so I'm going to be lazy and write 3x squared. And then in parentheses, I want to write down what's left. So from my first term here, I did not circle up negative 1, and I did not circle up these 2 x's. So if I put those, sorry about that, if I put those all together, I would have negative 1x squared. And then if I look at what's left over from the red here, the only thing left over is a 5, and it is a positive 5. So that is the factored form for negative 3x to the fourth plus 15x squared. And that's using basically what's called a prime factorization, okay, or if you remember doing factor trees. So that's one method to do these. Okay, I'm going to slide over to the next question here, next little problem. And I'm not so sure I want to do a prime factorization for negative 42, 60, and 24. So there's another method. Now what I'm going to do is I am going to eliminate, whoa, that was a little bit too much. I'm going to take out that 2 for the number of the problem, so I have some space to work. Let's see. All right. This is going to look a little bit weird, but basically what I'm going to do is I am going to do multiple steps of division. It's going to look weird because it's going to go upside down. And what I want to do is ask myself, what number, any number, can I divide into negative 42, 60, and negative 24? And if you want to go as simple as saying, you know what, I can divide a 2 into all of those. Start there. Literally start with any number that you can divide into it. So because it's division, I'm going to divide out I'm going to divide out a positive 2. So let's see, negative 21. I haven't touched the variables. We'll get there eventually. Plus half of 60 is 30. AB squared minus half of 24 is 12AB. Now I want to look and see if I can find another number, right, that can divide into my 3 terms. So what numbers am I looking at? Negative 21, positive 30, and negative 12. So negative 21, 30, and negative 12 have a common 3 in them. So I'm going to divide that 3 out. So negative 21 divided by 3 is negative 7, a cubed b to the 9th, plus 30 divided by 3 is 10 AB squared. Negative 12 divided by 3 is negative 4 AB. So now if I look at the numbers, I have negative 7, positive 10, and negative 4, and other than 1, no common number will divide into those. So let's start looking at the variables. And all I want to do is focus on one variable at a time. So I have a to the third, a, and a. So all three of these terms share a common a. So I'm going to go ahead and take out one single a from every term. So negative 7, I'm going to remove 1a, so now it's going to become a squared, b to the 9th plus 10. Well, I had 1a here, but I removed it. I'm dividing it out. So no more a's there. Minus 4, again, same thing. I had an a here, but I'm going to remove it, so just b is left. So no more a's, because only one term now has a's, not all three of them. How about b's? All right, b to the 9th, b to the 2nd, and I have a single b here, so I can only take one b out. So every single one of my terms, I am going to remove one b. All right, so that 9, I lost one of them. B squared here, I'm going to lose 1 and just have a b. And then 4b, that single b is going to disappear. It's going to divide out, just leaving that negative 4 behind. Now, we have what looks like an absolute mess here. It's really not that bad. So all of these pieces on the left here, I'm trying to see if I can get, there's my highlighter. Weird. So all of those pieces on the left there, including the 2 at the top, I'm not sure why it's close enough, are the GCF. So to finish up the answer, what we're going to do is multiply those together. So you've got 2 times 3 times a times b. So that would be 6 ab. And then this at the bottom is what's going to go inside the parentheses, because that's what remains when we have divided that GCF out. So negative 7a squared b to the 8th plus 10b minus 4. Close up the parentheses, and that is the factored form for that second problem. Okay, I've heard this referred to as the ladder method. I'm not sure if somebody just made that up, but basically what you're doing is instead of looking for the GCF all at once, you're just doing it in parts. And so find any number or any variable that you can divide out and take it out. All right, and keep going until you get to a point where the last terms down here, they don't have anything in common other than the number 1, and dividing out a 1 is not going to help. Okay, so that's 2 methods. And you might be looking at this going, I don't think I really want to do either of those. Well, depending on the size of your numbers, you might just be able to look at the numbers and the variables and figure it out in your head. All right? So 14, 8, and 18. The only number, common number, that will divide into all three of those numbers is 2. Okay, that's it. That's the biggest number that's going to go in there, the greatest common factor. And if we look at then the variables, we have n to the third, n to the second, and a single n in the last term. Because this last term only has a single n, that means I can only divide one n out. That's it. Okay? So that 2n is the common factor, the greatest common factor for those three terms. And I like writing these as little divisions, little fractions, to remind myself that I need to divide. So I'm going to take 14n cubed divided by 2n. I would have 7n squared. I'm going to keep going across and dividing. So plus, that would be 4n, and then plus 9. No more n's at the end. We get divided it out. So that's the factored form. Now, that particular problem worked out relatively nicely using that method because the numbers and variables were relatively small. Okay, so you might mix and match these methods and say, you know what, if the numbers are big, I'm going to do something else. If the numbers are small and I can do them in my head, I'll pick a different method. All right, last problem here, last example you're going to see, and this is problem number, I'm calling it problem number 4, it's the 4th example. All right, so we've got quite a bit of terms here. Lots of information coming in. I'm actually going to use that last method and just see if I can figure it out in my head. So negative 24, negative 30, no, it's a positive 36, negative 8, and negative 40. And I'm thinking I can take out a 4. Let's see if I take out a 4, what happens. Okay, so now let's take on the variables. So I've got y to the 6th, y to the 6th, y to the 7th, and y to the 8th. So the way I want to look at this is whatever the lowest power is, as long as all of my terms have a y in them. And the lowest power that shows up is y to the 6th. Okay, and now I want to look, I have an x here, but as soon as I see that this term does not have an x, I'm not able to take out an x as a common factor. So let's see here. 4, y to the 6th, I believe is the GCF. And I'm going to do my division to see if it actually works here. So let's see what we've got here. Negative 6, there's no more y's. They completely cancel each other out. Plus 9, no more y's, but the x to the 3rd is still there. Minus 2. Now I had y to the 7th, I divided out y to the 6th, which means 1 y is left over, minus 10 y squared x, and yep, that is 100% the factored form. All right, I hope this video has helped show you some methods for how to factor just using a GCF.